देखिए रोहित जी, ये बदले की राजनीति भारतीय जनता पार्टी नहीं करती है। जो भाजपा शासित राज्य है वहाँ नागरिकों के पास ये हक है कि कोई अगर फर्जीवाड़ा करे, फॉर्जरी करे, फ्रॉड करे, जो कांग्रेस अक्सर करती रहती है, तो एफआईआर दर्ज हो सकती है। ये कानूनी प्रक्रिया है। और रोहित जी, मैं तो इतना ही कहूंगा कि आप भी एक प्रतिष्ठित पत्रकार हैं, बड़ी निर्भीकता से अपनी बात रखते हैं। मुझे तो ये चिंता होती है कभी कभी कहीं ऐसा ना हो कोई आपकी बात उन्हें चुप जाए तो एक एफआईआर आपकी ओके। इसलिए मैं इतना ही कहूंगा, ये किसी
Hello guys.
द्वेष भावना से नहीं।
Morning, sir.
Good morning. Just give me 5 minutes, please. 3-4 minutes, please. No, tome acuerdo. Yo.
Ya pues yo dije like.
Okay, guys, let's start. One guy sent the email to me yesterday. His name is, what's the name? I don't know. Rain Gruber. Is he here or not? Rain Gruber.
I'm here, sir.
What's your name? Your name is Cooper, right?
Yes, sir.
What's your last name?
Lane, Layne.
No. I am asking for Rain Gruber. Reingruber.
I am here, sir.
Okay. Good. So, yesterday we went over the Riemann sum, left-hand rule, right-hand rule, midpoint rule. And I told you that if you increase the number of partitions, that means you are getting better and better approximation. First, we took 4 partitions, and then after we went for 16 partitions, and then after, in general, we went for n partitions, as n tends to infinity, means infinitely many partitions, means number of partitions. So that would give you better approximation, better approximate answer. So that's what we saw yesterday. And then after we went over a few of the properties of definite integral. And today we are going to see the fundamental theorem of calculus. There are two theorems, two fundamental theorem of calculus. Here, part 1, that is the first fundamental theorem of calculus. You can see over here, so far, whatever we have done, the range of the integration, that was the fixed number, real number, a to b. But here, f is a continuous function on the interval a to b. Just keep in mind this thing, we are working with Riemann integration. Riemann integration, the basic condition for the integration is your function must be continuous, because it's antiderivative process, and for derivative your function has to be continuous, right? Derivative means continuity. It is continuous and smoothness. So here integration, your function must be continuous in some interval a to b. But here the range of it, previously it was just a to b, but here the range is a variable. Look at over here, a to x f of t dt. So small f is a continuous function on a to b, and capital fx is the integration. So if you take the integration of this small f within the range of fixed a, some fixed a, lower limit fixed, but upper limit is a variable that is not fixed. And I give the name that is equal to capital Fx. If that happens, in that case, f is differentiable function on open interval a to b. Capital F is differentiable function on open interval a to b. Capital F is differentiable function means you can take the derivative of this function. If you take the derivative, that means you cannot take derivative just on left side. You have to take the derivative on sides. If you take the derivative over here, you are taking derivative over here. Again, integration derivative. Antiderivative means integration and derivative and antiderivative. The effect will be nullified, and you are getting back your function f. You are getting your function back. That is f or f of t. So that is the fundamental theorem. Only thing is whenever how to find the integration of the given function whenever upper range is not a fixed number, but it is a variable. So if that happens, then f is differentiable function and f dash x equal to fx. See, if you take the derivative, you're going to get your function back. But f dash x equal to fx, that means this is f of t. Try to understand, guys. Please try to pay your full attention over here, please. So f of x is equal to f of t. That means here your upper range, upper limit, your t is replaced by your upper limit. Whatever the function you are getting, your f, your small f, then after your t in your function is replaced by your upper limit. So please keep in mind this thing. It's very easy. Only thing is you need to pay little attention. Look at here. Suppose I give you one function, fx equal to, I'm providing you the function directly this one. Fx in this form. -5 to x. So -5 is my a. X is my b. Not b, actually variable. And t square plus sine t dt. T square plus sine t is my ft. T square plus sine t is ft. it says that whenever you go for f dash of this is a polynomial trig function. Polynomial is continuous, trig is continuous, summation is continuous, so this function is continuous. So f is continuous, first condition satisfies. Right? Question is, what is f dash x? What is the derivative of capital of fx? So f dash x is equal to, as I told you, that first of all, replace your variable t by upper limit x, variable x. So t is replaced by x, so x square plus sine x, x square plus sine x. And then take the derivative, because this is differentiable function. You are taking derivative over here, that means you have to have derivative over here. So take the derivative of the given function. So derivative of this upper limit actually. So derivative of the upper limit. Upper limit is x, d by dx with respect to x. What is the derivative of upper limit? That is simply 1. Agree? D by dx of x is simply 1. So that's why your answer is x square plus sine x. I repeat. First of all, try to replace your function ft by your upper limit. Variable t is replaced by the upper limit x, variable x. So x square plus sine x. And then take the derivative. Then take the derivative of the upper limit. Just forget about the function, derivative of the upper limit. Upper limit d by dx of x is just 1. And that's it. Second example. fx equal to 2 to x square ln t dt. First of all, this t is replaced by your upper limit. So ln of x square. And then go for the derivative of the upper limit. That is 2x. So ln of x square and 2x. So 2x ln of x square. Simple. Third one. Negative sign is there. Sorry, fx is equal to cosine x to 5 and t cube dt. Now guys, look at over here, please. Please look at here. All of you pay attention. This is in the reverse form. I must have my lower limit as a constant if I want to apply this first fundamental theorem of calculus. But here is the reverse form. My lower limit is a variable, upper limit is constant. That's why I gave you the properties yesterday. One of the properties of integration was integration a to b fx dx equal to negative of integration b to a fx dx. Do you remember this thing, guys?
Yes, sir.
Let me write it down for you. Let me write it down for you. Yesterday, I gave you one of the properties, integration a to b of fx dx. And if I want to flip the range of integration, means lower and upper limits, so it is b to a of f of x dx. Look at here, guys. Look at here, please. So I'm going to use this property over here because, as I told you, I want my constant is here as upper limits. I want to convert this one to the lower limit before I apply my fundamental theorem of calculus part 1. So negative sign is there and I can flip the range. Negative sign is there, I can flip the range and t cube dt. Now it is of the form given to you in the theorem. Now you can change replace your t by the upper limit. So it is t is replaced by upper limit. Please keep in mind this thing. So t is cosine x. So cosine x cube will be as it is. Margin cube will be as it is. So negative sign out, it is as it is. T is replaced by upper limit. So cosine x cube as it is. And derivative of upper limit. Derivative of upper limit is upper limit is cosine x. Derivative of cosine x is negative sine x. Negative will be positive. So you are going to get sine x times cosine cube x. Sine x times, this is sine x. Sine x times cosine cube x. And that is your answer. So
I have a question.
So let me finish, please.
Okay.
So whenever you write this thing at that time, it is irrespective of your lower limit. Here it is 5, here it is 2. We don't bother about it. It has to be just one constant. That's it. Question.
So you knew you had to switch the cosine 5 because you need an x on the upper limit. Is that right?
What? Cosine of 5? Where is cosine of 5?
And number 3.
Number 3, but I don't see anywhere cosine of 5. It is cosine of x.
Yeah, that's what I meant. That's what I meant. Is it because you need an x in the upper limit?
Yes, you have to have x or function of x, some variable function of x or x. Here you don't consider this one just x, it's a function of x, it's x squared, polynomial. Here trig function, first
Okay.
fx equal to x, linear function. So it's, don't think that you will be having just x over here. No, it has to be a function of x. It could be x, could be x squared, it could be x cubed, it could be sine x plus cosine x, something like that. But
Okay. Thank you, sir.
okay, good. Now my fourth example is negative x to x t cube dt. Look at over here, guys. Negative x to x t cube dt. Neither lower limit nor upper limit is a constant. But I want constant, otherwise I can't apply my theorem. So what I'm going to do, negative x to x, I'm going to divide into two parts like this, negative x to 0 and 0 to x. 0 is the most convenient number and it makes exactly your interval into two parts. So that's why I'm choosing my point 0 over here. So negative x to 0 and 0 to x. So negative x to x can be written in the form of negative x to 0 and 0 to x. Agree? This interval negative x to x is now divided into two parts because again I'm using one property. If you remember, I gave you another property, a to b fx dx. A to b fx dx. And suppose you have one number c between your range a to b. So you can write a to c of fx dx plus c to b of fx dx. C to b of fx dx. Am I right? That was one of the another property we saw yesterday, almost at the end of the class. Agree?
Yeah. Is there?
Good.
Yes, sir.
So same here. Here your c is 0. So negative x to 0 t cube dt and 0 to x t cube dt. I don't have any problem over for this part. Look at over here for this block. Right? Because it is 0 constant at as a lower limit, variable as upper limit. I'm good. But here again, I have to use my previous case. Right? Means I have to have my variable over here. So again, use the same, just flip this range by multiplying negative sign. Negative of 0 to negative x t cube dt and 0 to x t cube dt. Now I am ready to apply my theorem because now I am exactly of the given form in the theorem. So negative sign as it is, t is replaced by upper limit is negative x, cube as it is, and derivative of negative x is negative 1, plus t is replaced by upper limit x cube, and derivative of x with respect to x is 1. Simplify this one. Negative of x cube is negative 1 to the power cube and x cube. Negative 1 to the power cube is negative 1, this negative 1, sorry, and this negative 1 is 1. Negative is still outside, so negative of x cube plus x cube, that means your effect is nullified. So you are getting your area 0. You are getting your area 0. And that makes sense too. Suppose, look at over here, negative x to x is your range, right? X cube is a t cube or x cube is your function. I told you yesterday. Suppose I have negative 5 to 5, negative 5 to 5 x cube function. That means the graph of the function looks something like this. Graph of the function looks something like this. Suppose my x is negative 5. Suppose. Right? Now, if I want to, integration is again, continuous integration is nothing but the area. So, if you go like this, you are looking for the area of the upper part of x-axis and lower part of x-axis. Upper part of x-axis, here you are getting the area, that is what? That is equal to negative of x cube. That is lower part. Am I right? Yeah. And upper part is positive of x cube because you are getting same figure above x-axis and below x-axis. Above your area is positive, below area is negative. Same numbers means the effect will be nullified and you are getting 0. So this makes perfect sense. But only thing is your upper range is x, so it's a variable. But once you increase your x or once you change your x, Once you change your x, that x is changing on positive side as well as negative side. If you change your x, suppose x is, that means it is increasing or decreasing on positive side, and exactly simultaneously the same thing will happen over here on negative side. So every time you will be getting the area 0 because same area above x-axis, below x-axis, right? So that is the first fundamental theorem of calculus. Any doubt so far? I am waiting for your answer. Any doubt so far?
No, sir.
One more thing, guys. I want everyone to speak your name, please, because I don't want anybody to remain absent in the class. So please start with John Marshall. Go ahead.
John Marshall, I'm here.
Next.
Cooper Lane here.
Speak loudly. Speak loudly. Who is there?
Cooper Lane's here.
Cooper. Okay. Next.
McToon is here.
Good. Next.
Andrew Jarka here.
Andrew. Okay. Good. Next.
Jonathan Soto.
One by one, please. Say again. Who is there after Andrew?
Jonathan Soto here.
So, okay. Next.
Thomas Williamson here.
Williamson. Okay. Next.
Christopher Janelle here.
Who?
Christopher Janelle.
Okay. Christopher Chen. Okay. Next.
Evaner here.
T. Heavener. Okay. Next.
Rachel Zapweja here.
Rachel. Okay. Next.
Walker Powell here.
Walker Powell. Oh, okay. Good. Next. I was looking at you. Good.
Hi, sir. Alexis is here.
Alexa Davis, I can't see you. Speak.
I gotta go turn on my lights then.
Please, if you turn off your lights, and then probably you will be feeling sleepy. Don't do this thing.
Hi, sir.
Hi. Okay, Alexis Davis. How are you?
I'm good, sir. How are you?
I'm good. Thank you.
Good.
Next. Next.
Veer White is also here.
I can't hear you guys. Please speak loudly and keep
Veer White is
it
here.
on. Who?
Veer White is here.
Okay. Next.
Robert Glasgow here.
Robert. Okay, good. Next. Next.
Hayden Reingruber's here.
Who?
Hayden Reingruber.
Okay. Next.
Reese Seaman is here.
Brian Seaman. Okay, good. Next. Next. Where is Bud?
I was here, sir. I just
Lazera. Okay, Lazera. I was waiting for you. Good. Please don't waste time, please. And where is Bud? I can't see you, Bud.
I was here. I'm right here, sir. I just introduced myself, actually.
Okay. Hey, what's your first name? I forgot, Bud.
Veer.
Veer, Bud. Okay, sorry. Good. So I think all are present, right?
Caleb Carpenter here.
Caleb. Yes, Carpenter. Anyone left out? Let me check my list. Anyone is left out? No, that's good. Oh, big class. Okay, guys, let's continue. So any doubt in first fundamental theorem of calculus? If you have any doubt, please ask me. No, right? Let's go for the second fundamental theorem of calculus. If you remember, I think I explained to you, right? Second fundamental theorem of calculus. Here I am looking for Nina Rodriguez. She is not here today. Nina Rodriguez, right? No, I'm sorry. Nina Rodriguez is in the other section. I'm sorry. You're good. Okay. So second fundamental theorem of calculus. Now, one more example. Look at over here. Here on the right corner, right lower corner of the previous page, just look at my cursor. Can you see my cursor? This is the example from your practice test. So if you have fx equal to 0 to sine x, root t sine t. So again, t is replaced by your upper limit, so root sine x, and derivative of sine x is cosine x, right? Derivative of sine x is cosine x. Okay. Now let's go for the second fundamental theorem of calculus. If f be a continuous function on the closed interval a to b, just same condition like the first one. Capital F be any antiderivative of f. Antiderivative, just like the case of first one. That capital F is the antiderivative of small f. So if you take the integration of a to b fx dx, that means you are getting fx. This is the definite integral, a to b. Look at over here. So if you take, so what it says, this theorem says that first take the integration of your function, this one, and then plug the limit as lower limit x equal to a and upper limit x equal to b. Replace your x by upper limit b and then replace your x by lower limit a. Look at here, fb and a in between negative sign. So it is fb minus fa. And this is called the second fundamental theorem of calculus. You will be using this thing now onwards till your education is complete. Maybe up to your graduation, if you are thinking to go for the higher study, for your graduation, again, you will be working with this, you will be using the same thing. Suppose somebody wants to go for the PhD or like this, again, you will be using this type of thing so many times very frequently. Second fundamental theorem of calculus, very frequently. So please guys, pay attention. Okay, I think you have used this thing probably in your Calc 1 last chapter also. I'm not sure, but I think, yeah, you have used this one. Yeah, you have used this one. Second fundamental theorem of calculus. This is just a revision for you. 0 to 4, 4x minus x squared dx. You know that whenever plus or minus sign is there, simple polynomial, that means you can go for term by term integration. This theorem says that first of all, take the integration of this given function fx. My function here is 4x minus x squared. Integration of this 4x is 4x squared by 2. Agree? Where?
Yes, sir. Sounds good.
4x squared by 2. My integration of x squared is x cubed by 3. X cubed by 3. This theorem says that take this lower limit over here, upper limit over here. So it is x equal to 0 to 4. So many times people, they speak like this, 4 to 0. Don't say 4 to 0. Usually you have to be habituated of speaking like 0 to 4. 0 to 4 means first you go for the lower limit and then upper limit. Okay, then replace your, see, cancel the common things. So here 2 2s are 4. So you are getting 2x squared minus x cubed by 3. X runs from 0 to 4. Replace your x by 4. So this x is replaced by 4. 4 square is 16, 2s are 32. This x is replaced by 4. 4 cube is 64 divided by 3. 64 divided by 3. Then after replace your x by 0. So x equal to 0 and x equal to 0. So whole part is 0, no need to write. Means we are taking this one, right? This 0, 0, no need to write. And if you replace by x by 4, you are getting this part. So that is 32 minus 64 by 3. And if you take the LCM, 32 is common, 1 minus 2 by 3. LCM is 3. 3 minus 2, that is 1 by 3, 32 by 3. And that means 10.666. So that is the answer. Now, why I chose this function? Do you remember that I have been working with this function since last 2 days? 4x minus x squared. We found the upper limit, left-hand rule, right-hand rule, midpoint rule. Integration was 0 to 4, exactly same range, same function. Am I right? Right? And
Yes, sir.
I got my answer for force strip. It was 10. Right-hand limit, left-hand limit. Midpoint rule, right-hand rule, left-hand rule. Force strips, answer was 10. Midpoint rule, it was 11. Then after I increased my strip to 16 and I got something 10.625 for left hand rule, right hand rule. midpoint rule, I got 10.8 to something like that, right? By Riemann sum. Riemann, he figured it out, this thing. You don't have to go through all lengthy process of summation and all these things, whatever we did yesterday. No, Riemann found, this technique of integration. And he said that if you take the integration of this one, and plug the range, you are getting this 10.666 exact answer. Look at over here. 10 point. And you know this 10.666, we got the same answer for same function, same range for infinitely many strip, general n. Do you remember this thing yesterday, almost at the end of the class? When I took n tends to infinity, my answer was same. So whatever long process we did yesterday, that is summarized like this. Just take the integration, you are getting the same answer. That's the area. Ancient way of doing was the Riemann sum. That was just the summation. But Riemann, he found this, thanks to Riemann. And that opened a door of calculus. This integration technique opened a door of calculus in 16th century, 16th, 17th century, yeah. Anyway, one more practice test problem, exercise 1, question number 5, integration 5 by 6 to 5 by 3 cosecant x cotangent x dx. Right? This is first fundamental theorem of calculus. Oh, sorry. Okay, this is sorry, my bad. Just the integration. So cosine, second fundamental theorem of calculus, cosecant x and cotangent x. Integration of cosecant x, cotangent x is negative of cosecant x, or other way around. Derivative of cosecant x is negative cosecant x, cotangent x. So integration of cosecant x, cotangent x is cosecant x. Use your formula sheet, first page. Range is pi by 6 to pi by 3. Replace your x by pi by 3. Replace your x by pi by 6 in between negative sign. Take this negative out. So cosecant pi by 3 minus cosecant pi by 6. Use second page of formula sheet, unit circle. Cosecant pi by 3 is 2 over root 3 because sine pi by 3 is root 3 by 2. Sine pi by 3 is root 3 by 2. So cosecant is 1 over sine, so 2 over root 3. Cosecant pi by 6. Sine pi by 6 is 1 by 2. Sine pi by 6 is 1 by 2. So cosecant pi by 6 is 2. So if you simplify this one, 2 minus 2 over root 3, that's the answer. If you want, you can use your calculator. You are going to get the answer in decimal. And that's it. Same here. Some of the examples I solved from your practice test. 5, 6, 9, 10, some random examples. Okay, for you guys, just to help you out. But that doesn't mean that you ignore these examples. You have to write down the same examples in your homework assignment submission, please. Okay. Okay, then let's go for one more example. This is, I think, easiest one. E to the power theta integration is e to the power theta. Sine theta integration is negative cosine theta. Guys, please keep in mind this thing. People are always getting confused between integration of sine and cosine and derivative of sine and cosine. So many times they are getting confused and that's why they are losing their points. So please be careful. Derivative of sine x is cosine x. Derivative of cosine x is negative sine x. Integration of cosine x is reverse way now. Integration of cosine x is sine x. Integration of sine x is negative cosine x. So please, please, please keep in mind this thing, please, always. So same here, just a derivative, and then after replace your theta by, because theta is a variable, theta by upper limit 1, lower limit negative 1. So upper limit 1, lower limit negative 1. But cosine theta is an even function. Cosine is an even function, sine is an odd function. Please keep in mind this thing. Even function definition, I think I gave you the definition yesterday, am I right? Yes or no? For even function?
Yes, sir.
Yeah, so f of negative x equal to fx. So cosine of negative x equal to cosine x, that is the even function. So we can ignore this negative sign, so it will be cosine x. So it's cosine 1 actually. E to the power 1 minus cosine 1 minus e to the power 1 minus plus cosine 1. Minus cosine 1 plus cosine 1. This is a printing mistake. It has to be negative and negative is 1. It has to be plus y. I think I did something wrong here. Cosine is an even function. So this part is just cosine 1. So here it is cosine 1. This negative has to be positive.
Yeah,
I don't know why it should be
plus
positive.
cosine.
I'm sorry. So cosine 1 and cosine 1 will get cancelled out. And finally, we are getting e minus 1 over e. This will not appear. I'm sorry. This is my bad. Just remove this one. I'm sorry. So I have how to use the pen. I don't know. Let me use the pen and try to remove this part so that. No. Okay. Somewhere here. I heard that icon over here. I don't know where I lost. Where somewhere. Oops. What I did. Oh my gosh, what I did. Okay. Let me use this icon. And let me, something was there, eraser and everything was there. I don't find it. Do you find it? Some eraser or something like that? So, I want to write plus sign here. And I want to remove this part. Just erase this part, right? This is plus sign and erase this part. So answer is this one. Okay. Where is eraser? I think I need to fix this one. Something I'm missing. No. I am missing something. Okay, that's fine. I will figure it out.
Sir, for problems like this in the last one, would you want us to go into that decimal form, or do you want us to just?
I am good with e minus 1 over e. If you want to plug the value of e equal to 2.7 to whatever it may be, and if you want to go for decimal, that sounds good to me. It's your choice. Okay, one more example. Example number 9 from your practice test. Integration 1 to 4 u minus 2 over square root of u du. Right? See, every example is different. You have to figure it out, the proper technique of solving that example. So u divided by square root of u, that is here 2 divided by square root of u. So now I am getting term by term integration because it's a plus minus sign in between two functions. U to the power 1. How can I get my cursor? U to the power 1, and here it is 1 by 2. So in the numerator, base is same, quotient is there. So u to the power 1 minus 1 by 2. So u to the power half. U to the power 1 by 2 in the denominator, let me bring it over here to the numerator. So u to the power negative 1 by 2. Integration, use the power rule now. Integration 1 by 2, u to the power 1 by 2 is just add plus 1 and divide by the same number. You know this power rule, am I right? Very first day, integration x to the power n equal to x to the power n plus 1 divided by n plus 1. Yes or no? I think you forgot. Do you forget this thing, guys? Integrate.
No, we got it, sir.
X to the power n dx equal to x to the power n plus 1 divided by n plus 1 plus c. This is called the power rule. This is called the power rule. So here your n is replaced by 1 by 2, sorry. Yeah, n is your 1 by 2. So 1 by 2 plus 1 is 3 by 2 divided by the same number. Negative 1 by 2 plus 1 is 1 by 2 divided by the same number. Range is 1 to 4. Replace your u by 4. Now guys, please be careful. Now guys, please be careful. I just want you to look at my work because we will be using this type of stuff so many times in future. So that's why I just want you to look at here. Look at here, I mean to say that here I'm getting 2/3, my last step, 2/3 u to the power 3 by 2 minus 4 u to the power 1 by 2, and the range is 1 to 4. Agree? Look at here, my last step. The range is 1 to 4. Okay. Now, what I'm going to do, I'm replacing my u by 4. So it is 2 by 3, 4 to the power 3 by 2, minus 4, 4 to the power 1 by 2. First part. Second part is replace u by 1. So 2 by 3, 1 to the power 3 by 2. And 4, 1 to the power 1 by 2. I'm getting like this. Agree? Agree?
Yes, sir.
All of you?
Sir.
All of you girls?
Sir.
Yes, sir.
Rachel, Davis, Alexis?
Yeah.
Good. Alexis, why are you laughing? Who is there?
That's my, I'm talking to my mom.
Oh, okay. Good. So now mainly you need to focus on the first part. Just look at over here, the first part. It is 4 to the power 3 by 2. Whenever you have this type of stuff, how can you go for the simplification? How can you simplify this one? Right? Just take that is equal to 2/3, and 4 can be written as 2 square because you are having power 3 by 2. Minus again 4 can be written as 2 square and power 1 by 2. Power 1 by 2, like this. Look at here. Agree? Agree?
Yes, sir.
Yes, sir.
Yes, sir.
So that you can cancel your 2 and 2. So this 2 and 2 will get cancelled out. Look at here. Agree?
Yes, sir.
Say
Yes, sir. Yes, sir.
yes. Right. And other part as it is. So 2/3 because 1 to the power 3 by 2 is 1. 1 to the power 1 by 2 is 1, so as it is. So now it is 2/3. And what is left out? Now 2 cube. 2 cube is 8. Minus 4, 2. Minus 2 is common. So 1/3 minus 2. Shall I write like this? Shall I write like
Yes, sir.
this? Alexis,
Yes, sir.
Rachel.
Yes, sir. I see it.
Okay. Good. So that is equal to, let me take 2 out from my first part also. So I'm getting 8 by 3 and 4 also out, right? So 4 also out. So I'm getting 2 by 3 over here because 4 2s are 8. So actually I'm taking 8 out because this is 8. So I'm taking 8 out. So 2 by 3 minus 1, minus 2 out, 1 by 3 minus 2. Agree? Look at here. Yes or no?
Yes, sir.
Yes, sir.
Yep.
Nick, Heavener,
Yes, sir.
good. Okay, that is equal to 8, 2 by 3 minus 1, LCM, 2 minus 3 by 3, so negative 1/3 minus 2, 1 by 3 minus 2, that is equal to 1 minus 1 by 3 minus 2. That means it is 1 minus 6 divided by 2, so negative of 5 by 3. 1 minus 6 divided by 3. Agree?
Yep.
That is equal to negative of 8/3, negative, positive of 10/3. So 8 plus 10, that is equal to 2/3 must be my answer. Agree?
Yes, sir.
Okay. So that's how you can solve the example. So whenever you have something like this, always convert your 4 in terms of, now look at here. Always convert your 4 in terms of 2 square so that you can cancel 2 and 2, 2 square cancel 2 and 2, and simplify this one, and you are getting 2/3 as the answer. You are getting 2/3 as the answer. Okay. Next is mean value theorem. MVT. MVT, mean value theorem. Mean value theorem. MVT. Okay. Integration a to b fx dx is equal to f of c b minus a. Actually, it is f has to be a continuous function. I did not write this thing over here, but please keep in mind this thing. Your small f has to be a continuous function in the closed interval a to b. Then, and c is any point between the closed interval a to b. C is any point between the closed interval a to b. Then integration of a to b fx ds equal to f of c times b minus a. Value of the function at that point c times b minus a, upper range minus lower range. That's called the mean value theorem. That's called the mean value theorem. So your continuous, f is continuous function from the interval a to b. C is any point in between a to b, not necessarily middle point. Okay, any point. Any point. It could be over here. C could be over here. It could be over here. Here, anywhere between a to b. Right? So you can write the value of the function at c like this, f of c and this b minus a. So that is called the mean value theorem. Mean value theorem. Actually, we have Rolle's theorem. I don't know whether you know about this thing or not. So Rolle's theorem says that f is continuous. If f is continuous, f is differentiable, and fb equal to f of a. Value of the function at the upper limit, it must be equal to value of the function at the lower limit. So let me write it down for you here so that you will be having more idea. Rolle's theorem. Rolle's theorem says that f is continuous on the closed interval a to b. F is differentiable on open interval a to b. My first condition, second condition, and third condition. F of a equal to f of b. F of a equal to f of b. That means suppose I have one function. This is my a and this is my b and this is my fx. So f of a and f of b. Look at here, like this. If f is continuous on the closed interval a to b, f is differentiable on the open interval a to b, fa equal to fb. Fa equal to fb. Then there exists one number c on the open interval a to b such that f of c equal to 0. F of c equal to 0. Whenever your fa equal to fb, look at over here. Fa equal to fb means function moves like this. Fa, value of the function at a and b are same. Value of the function are same. That means function is increasing like this and then decreasing. That means you are going to get at least one point over here for which f dash c equal to 0. F dash c means if you take the tangent line over here, that tangent line is parallel to x-axis. F dash c equal to 0 means slope is 0, means tangent line is a constant function, tangent line is parallel to x-axis. So there exists at least one c over here, one c, such that f dash c equal to 0. Such that f dash c equal to 0. That is called Rolle's theorem. Did somebody provide me his or her cell phone number? Did I ask you for the cell phone number and I take the picture and send it to you?
Yes, you sent it to me, sir.
Nick, right?
No, John.
Oh, John. Sorry, John. Okay. So today also, if you want, I can take the picture and send it to you. Is it
Please
okay?
do. Please do.
Okay. So f dash c equal to 0. Now, our mean value theorem says that Look at here, guys. Mean values theorem, that is the advanced version of Rolle's theorem. Or other way around, you can say that mean value theorem, that is the generalization of Rolle's theorem. Why generalization? Because mean value theorem, it says that if you drop the third condition, FA equal to FB, if you drop this condition, in that case, you are going to get, so let me write it down over here, mean value theorem. Mean value theorem. So first condition, F is continuous on the closed interval A to B. Second condition, F is differentiable on the open interval A to B. That's it. Then there exists one C on the interval A to B such that F dash C equal to FB minus FA divided by B minus A. FB minus FA divided by B minus A. That means your picture will look like this one, F of A and F of B. Look at here. So F is continuous on the closed interval A to B. Continuous function is there, curvature. But FA and FB, they are different now. They are not same. Value of the function at A is this one, at B is this one. They are different. So in that case, you can measure FB minus FA divided by B minus A, that is your slope. That is your slope. That means it says that there must exist one point C over here, for which if you take the slope, at F dash C, F at C, that slope is measured by FB minus FA over B minus A. Here if you take the slope, in the first case, if you take the slope, it was just parallel to x-axis for Rolle's theorem, and that's why slope was 0. Here slope is not parallel to x-axis, and that can be measured like this. But here, in this Rolle's theorem, in this final, Maclaurin's theorem, mean value theorem. In this mean value theorem, if you consider in this mean value theorem, look at here, guys. If you consider FB minus FA equal to FB here, what will happen if you take FA equal to FB in the numerator? It is 0, agree? If you consider equal to FB here, means F dash C equal to 0 and you are going back to Rolle's theorem. That's why I told you that mean value theorem, that is the generalization of Rolle's theorem. Does it make sense?
Yes, sir.
Right? So another form of this one, FB minus FA over B minus A, the same thing, and F dash C. So let me write it down like this. Look at here. In your book, it is mentioned like this one. But how this one comes, that's what I am explaining to you. Can you see my rectangle here? Red color rectangle?
Yes, sir.
Yes, sir.
Right? What I'm going to do, just look at over here. I'm multiplying both sides by B minus A. So if I write like this, FB minus F of A equal to F dash C times B minus A. Shall I write like this? Look at here, guys. Shall I write like this? Yes or no?
Yes, sir.
Yes,
Right?
sir.
But what is my left hand side? FB minus FA. FB minus FA, that is nothing but, yes, that is some function. So I can write fx dx and integration x equal to A to B. And that is equal to F dash C times B minus A. This FB minus FA is nothing but the, like this. Right? Because that is the integration, and then we replace by upper limit by x and lower limit by x in between negative sign. So that's how it is developed. So that is the reason I told you that mean value theorem, that is, let me take the picture and send it to John. So all you guys will be getting the same thing. BMI, John Marshall, okay, message. Okay. So whole page will be with him shortly. Right, guys? So that is the mean value theorem. Okay. So now question number 3 from your practice test. Whenever you find this P dot T dot means it's a practice test. So fx equal to, it says that fx equal to 2 minus 2 x minus 2 root 2 x in the interval a to b. Apply mean value theorem. So 0 to 2 fx dx, 0 to, that is my integration range, 0 to 2 fx dx. That is my left hand side. Agree? Left hand side is this one. This is my left hand side. 0 to 2 fx is x minus 2 root x, x minus 2 root x, and dx, and dx. So that is again use power rule. X integration is x square by 2 minus 2x to the power half. Integration is x to the power 3 by 2 by 3 by 2. And 0 to 2. Second fundamental theorem of calculus, replace this x by upper limit and then replace both the x's by lower limit. So you're getting this one. By lower limit, this x and x 0, so no need to write. Just upper limit will work over here. So 2 minus this one, just simplified. Simplify this one, you're going to get this as the answer. So that is my left hand side. Now I want to check my right hand side. I must get the same answer for this mean value theorem. This mean value theorem is known as Lagrange's mean value theorem. Lagrange, he figured it out, this thing, and that's why it is called Lagrange's mean value theorem. Lagrange's mean value theorem. Lagrange apostrophe S, mean value theorem. Okay, then right hand side is FCB minus A. F of C, value of the function at C. We don't know FC, so keep this FC as it is. B minus A, that is B is 2, A is 0, so 2 minus 0 is 2. 2 times FC. 2 times FC. So 2 times FC. My function is x minus 2 root x. I want FC, so replace this x by C. So C minus 2 root C. C minus 2 root C. So I'm getting 2 times C minus 2 root C. Lagrange's mean value theorem says that you can equate both of these, left side and right side, equate them, equality sign. So here my left side was 2 minus 8 by 3 root 2. My right side is 2 times C minus root C. So just equate them. Here I have to, here, yeah, you can do like this. I'm looking for C, please keep in mind this thing. I'm looking for C. So C says that 2 minus 8 by 2 root 3 and this one, okay. Divide by 2 throughout. If you divide by 2, you are going to get like this. 3 minus 4 root 2 by 3 is C minus 2 root C. Now we are looking for C. How can you get C? You have to have good algebra skill. Because here it is C, here it is square root of C. You are looking just the value of C. So C minus 2 root C. What I'm going to do, I'm going to add 1 both sides so that I can make the perfect square over here or kind of things. Yeah, perfect square here. And then after I can find my C. So adding 1 both sides will give me this one. C minus 2 root C plus 1 equal to 3 minus 2 root 2 by 4 root 2 by 3 plus 1. This is root C minus 1 whole square. This is a perfect square. Quadratic equation. You know this thing, right? X square or ax square plus bx plus c equal to 0. Quadratic equation solution is x equal to negative b plus or minus square root of b square minus 4ac divided by 2a. Agree? How many of you don't know about the quadratic equation? Please let me know. Say your name. Means all of you know about the quadratic equation, right? Sounds good. So root c minus 1 whole square, that is equal to this one. LCM is 3. LCM is 3. So divide and multiplied by 3 here. So you are going to get this LCM. This 3 and 3 is 6. So 6 minus 4 root 2 by 3. This c minus 1. I'm looking for C. Please keep in mind this thing. So because of this perfect square, I have just one C now. One C here now. Oh. Just one C. So if I take the square root both the sides, so C minus 1 on left side and square root of this part. You can use your calculator. I don't mind. But make sure because of this square, see x equal to, guys look at over here, x square equal to 25. What is the value of x? X square equal to 25. What is the value of x?
5, sir.
Oh, no, it's not 5. X square equal to 25. Okay, other way around. Suppose I give you x equal to 5. What is the square of, what is the square? What is x square?
25.
25.
Okay. If I give you x equal to negative 5, what is the square of x?
25.
So if x square equal to 25, what is the value of x? Or what are the values of x?
Oh, plus
5 and
minus.
negative 5.
Plus or minus 5. Are you getting me, guys? So
Yes, sir.
you have to mention here plus or minus. John, are you okay? You are looking sleepy.
I'm good.
Good. So root C minus 1 equal to plus or minus 1, 6 minus 4 root 2 divided by 3. Right? So naturally, just send this 1 to other side. So root C equal to 1 plus or minus 6 minus 4 root 2 by 3. That means you will be getting two values. So 1 plus, if you use your calculator with 1 plus this one, you are getting this one. 1 minus this one, you will be getting this one. And make sense. I mean, make sure. What was your interval? Your interval was, in the beginning of the example, the interval was 0 to 2. So whatever two values you are getting right now, you have to pick just one or both of them. Depends on your interval. Make sure your values or value must lie within the range of the integration, within the range of interval. If your C value is lying outside the interval, that is not valid value. Just keep that value. Are you getting me?
Yes,
Are you
sir.
getting me, guys?
Yes, sir. Yes, sir.
Yes, sir.
Good. Nick, are you okay?
Yes, sir, I'm all good.
Good. Veer?
I'm good, sir.
Okay. So 1.79 lies between 0 to 2. 0.43 also is lying between 0 to 2. That means both the values are valid values because both are lying between 0 to 2. That means instead of one C, you will be getting two C's for which FB minus FA or B minus A, that is your F dash C or F dash C1. See, one is over here. You can take one slope over here and you can take another slope over here. So two values. So it's not like this. Mean value theorem, just for the explanation, we can say that there exists at least one C. Actually, see, I have not written down that word, but let me write it down. There exists at least one C. ATLEAST. At least one C. Because at least one C means at least one. At minimum one value you are getting. Maybe 2, maybe 3, maybe 4. Depends on the value of the function and the quadratic equation, biquadratic equation, which type of equation is provided to you. Right? So at least one makes a big difference over here. There exists at least one. See, intentionally I did not write at least one in the beginning, but because I wanted to let you know this thing, this example, so that you can come to know about the importance of this word at least. Make sense?
Yes, sir.
Good. Yeah. Yeah, good. And I think who sent the email to Mac Becker yesterday?
That was me, sir.
Yeah, thank you so much, because Becker, he just came back to me around 11 p.m. And then after we had a Zoom meeting at 1:30 and he taught me how to put all these videos on YouTube. So now everything is on YouTube. Okay. Daily I am putting all the videos on YouTube. So I think you will be good. And I made, I made the folder like Calculus 2, Calculus 3, then DFQ. I'm putting all my classes, all my class notes on YouTube. So you guys will be good, right? In future also, suppose, of course, most of you guys will be going for DFQ. My videos will be there if you want to use those videos, okay? I'm not
Thank you, sir.
I'm not going to delete anything. So if you want to take my help or my videos help, I mean to say, you are free to do that thing. There is no obligation. Okay, guys?
Thank you, sir.
Once you are my students forever. Okay, at least up to till the time of graduation. Okay, till you are graduating. Okay, guys. So I'm not going to delete anything, and everything is well mentioned over there. At least DFQ course, some of the portions of Calc 3 also I'm going to put it over there on YouTube. DFQ whole course will be there on YouTube, so you guys will be good. Okay, and that will be a big help because DFQ course right now is going on in full details. Everything is explained very nicely, and I'm putting all these videos daily base, so you will be getting everything. Okay, and one guy in our section, he's from Pacific, and he took my permission not to attend the class because I can understand that thing. Pacific is 3 hours behind than the Eastern time. So our class starts at 7:30, so he has to get up at 4:30. John, I'm sorry, I did not give that opportunity to you, that facility to you, but for that guy, I gave that opportunity because 4:30 is too early, right? And yeah, he's in our section. So he is requesting me every day for the videos and like this. So I think that will be a big help for him. Probably today he is going to see this video and he will be laughing, right? Or other way around, I would say he will be satisfied. Anyway, guys, so let's continue. So that's how this was the relationship between the Rolle's theorem, mean value theorem. At least C1C will be there so that you will be getting F dash C equal to FB minus FA divided by B minus A. Okay, next example, just the repetition, Fx equal to cosine x. This example is also from your practice test. See, again, I'm helping you, right? You guys must be feeling good. Am I right? So Fx equal to cosine x negative pi by 3 to pi by 3. Left hand side negative pi by 3 to pi by 3. A to b cosine x dx. Integration of cosine is sine x. Range is this one. Second fundamental theorem of calculus, sine pi by 3 minus sine negative pi by 3. Sine is an OR function, so this negative sign will come over here. So it is plus, so it is 2 times sine pi by 3. Sine pi by 3 is root 3 by 2. So you are getting just simply root 3. 2 and 2 will get cancelled out, right? So just root 3. Okay, so that is my left hand side. My right hand side, b minus a half of c. B minus a is pi by 3 minus pi by 3. So it is, yes, 2 pi by 3. And f of c, fx is cosine x, f of c is cosine c. So cosine c. If you equate this left side and right side, so it is, okay, that's fine. Root 3 by 2 equal to 2 by 2 will get cancelled out. So cosine c is equal to 3 root 3 by 2 pi. So c equal to cosine inverse of this function. Use your calculator. C equal to 0.571. Then for this value of c, you will be getting that slope f dash c equal to fb minus fa over b minus a. Okay, guys?
Sir.
Good. You need a rest?
Sir, for the test specifically, would both of these mean value theorem questions be likely? So like around the same level? Because like specifically B compared to A, or like the first mean value theorem that we did versus like this one that we did is significantly different levels. So would we be expected to, would it be about the same level right here?
Actually, first means what you mean by first. First, I gave you Rolle's theorem, and the second one is the mean value theorem.
So this part right here on this one that we were doing here, compared to the bottom one.
What is this part means? It is the practice test.
Yes, the first practice test question that you gave us, right here, compared to B. Which one like are the same level?
Either one.
Okay, thank you, sir.
Yep. Both are good. Ultimately, both say the same thing.
Yes, sir.
So either one. Only thing is I want the right method and right answer. That's it.
Yes, sir.
Right. If you want to go to Interstate 81 and if you from VMI, If you take the first interstate 64 and then merging 81, sounds good. Otherwise, go to exit 195 and go to 81, sounds good. Right? Right.
Yes, sir.
Right
Yes,
route
sir.
and right destination. That's it.
Yes, sir. Thank you.
That's fine. Okay, second part or third part actually, the average value. Oh no, sorry. You need a break of 5 minutes, right? Okay.
Yes, please.
Okay. That's fine. Okay, guys. Guys, I have one request. When you, hello, all of you are here?
Yes, sir.
All of you, Jonathan, Soto, Nick is here, John Marshall is here, Veer, girls. Davis is not here. Hey, Jonathan. Sort of. Five minutes means 5 minutes. This is not fair. Powell, Walker Powell. This is not fair. Yes, people are here now. Guys, 5 minutes means 5 minutes. Don't take more than 5 minutes, please. Jonathan Soto, I have one question for you.
Yes, sir.
Are you playing guitar?
I am not. They're just hanging. I do play guitar, but they're just hanging there.
So you're not a good player of guitar?
I'm okay.
You know, it was my passion when I was in my childhood, around when I was in 6th and 7th grade. It was my passion to learn, just to have one mastery on one instrument, one musical instrument. But somehow I couldn't do it. I don't know why. Yeah. So whenever I see guitar or somebody, I see somebody playing guitar, I like it. I just remember my past, my childhood. Yeah. Okay, all of you are here, right? Okay, next time, yeah, guys, I just have one request. If you look at my video on YouTube, just subscribe me, okay? Please.
Can you just look up your name and it'll...
Yeah. Thank you. Let's go. Let's move further. Average value. Okay. Average value is just the integration. Just integration, nothing else. Only thing is, whatever integration value you are finding, divide by the range of integration. That's it. I mean to say that, see, fx equal to 4 minus x square negative 2 to 2, right? What is the integration of this one? Negative 2 to 2 fx dx. Integration of 4 is 4x. X square is x cubed by 3. Negative 2 to 2. Fundamental theorem of calculus, second part, means you are getting 32 by 3. Agree? 32 by 3. Average value means whatever the values you are getting over here. Look at my cursor. Divide by this range. 2 minus minus 2. Divide by b minus a. 2, b is 2, minus 2. So divide by 1 by 4. So 32 by 3 divided by 4. So you are getting 32 divided by 4 times 3. 4 times 3, it is 8 by 3. That's it. Simple. So average value means just the integration. Once you get the integration, divide that number by your range. 2 minus 2, 2 minus minus 2. So 2, it's 4. Divide by 4. That's it. Here, fx equal to x square. Integration x cubed by 3. Range is 0 to 4. You are getting 16 by 3. Divided by 4. 4 minus 0 is 4. So 16 divided by 3 times 4. That means it is 4 by 3. Where is it? Oh, it's x cubed by 3. My bad. So x cubed by 3. X is replaced by 4. 4 cubed is 64. 64 divided by 3. That's the answer. And if you divide by the range, it's 16 by 3. Easy. Right? Okay. Okay. And now I want to skip this part intentionally. Sketch the graph of f and find the area of the enclosed region. Question number 5. I want to skip this thing because, of course, it is there in our book, but I want to skip this part because this is, in my opinion, this is the article based on the application of integration. If you remember, I told you very first day on Tuesday that I'm not going to ask any question based on this question 5 of the practice test, means sketch the graph of f and find the area enclosed by the region. But I will be asking the same thing in your third test, chapter 7, as article 7.1. Make sense? So right now, let me skip this part and let me move to the last portion of your syllabus, numerical integration. Last portion. Now I have one request, guys. All of you, I want to talk to all of you, please. Let me just highlight this one. Yeah. I want to talk to all of you. Please pay attention, guys. All girls, everyone, please. Glasgow, Robert Glasgow, Andrew, Jarka, yes, Walker, and Lazara. Yes, I'm sorry, I can't pronounce your name clearly, sorry. Lazara, right? Hilwe. Yeah, Maza Hilwe. Okay, good. And Simon, yes. Safar, okay, Cooper, Rachel is there, Christopher is there. Is, how are you? I'm sorry. We couldn't talk. We didn't talk, right? We did not talk. Today we did not talk, right? Is.
I'm good.
You're good? Good. Okay, fine. And who is left out? I think everyone is there. Peton.
Sir.
I can't see you. Kabel is there. That's good. Peton, I can't see you. Now here you go. Good. Okay, guys, look at here. I want to finish this article in next 15 minutes. And then after, if it is possible, it's a request. I know we have decided that you guys can go for the exam on Tuesday because Monday is a Memorial Day, but Tuesday you can take your exam. But I think that's not a good idea. What we are going to do tomorrow, I'm going to start the new chapter. I can't waste 2 hours. And that will not be the part of the syllabus for the first test. And when we will be continuing on Wednesday, at that time, you will be forgetting lots of things, whatever we are going to cover tomorrow. Rachel is laughing.
I'm sorry, sir. I just saw
No,
the
that's
chat.
fine. That's fine. Yeah, I like smiling faces. I want all you guys always with a smile. That's good. Okay. So my request is, if it is possible, you can take your exam tomorrow. Is it okay for you? Everything I explained to you, lots of examples I have solved from a practice test. I can give you one relaxation. You can submit your homework assignment on Monday or Tuesday. I don't mind.
Sir, for the formatting.
Let me finish. But if you take your exam tomorrow, you will be out of tense because if you are taking your exam on Tuesday, every time in this long weekend, it will be pinching you that no, you have to be well prepared. You have to be prepared with your exam like this. You have to work hard like this. But once you are done, you will be free. So that is just a request. I requested the same thing to my DFQ class, 9:45 to 11:45, and they agreed with me and they are taking the exam tomorrow. But because already we decided on Tuesday, but I just would like to go for the majority. What you guys think about this thing? Would you like to take your exam tomorrow?
I have a few questions about the format of the exam. If
Go
we're
ahead.
going to take it tomorrow. So how is it formatting? Are we taking it over Zoom, or like are you just sending us it and you have an hour to complete it in the scheduled class time?
Good. Look at here. You have to remain present on Zoom.
During the
First
entire
thing, during the entire time, so that I can watch you.
Okay.
That doesn't mean that I don't trust you. No, I do. But I just want you to remain present on Zoom. I am going to post your exam at 7:30 on Canvas in the assignment section. Exactly 7:30 or 7:45. I think, yeah, exam starts at 8. That's what we decided. So I'm going to post your exam at 7:45, around 7:45, I would say, 8:45, 8:50. So that in first 5-10 minutes, you can print out of the exam and you can start your exam exactly at 8, and your time gets over at exactly 9. Again, I'm going to give you 5 more minutes so that you can summarize all the things. You can arrange your pages in a sequence. You can scan the pages and again submit to the Canvas in the assignment section. So exam would be conducted like this. Any other question? And I will be grading, speed grader I'm going to use, grading your exam so that you will come to know what you made wrong, what any kind of suggestions I'm going to explain. I'm going to say everything. See, man, he knows this thing, right?
Yes.
Couple guys, they know this thing, yeah, because they took the course just before month with me. Anyway, so yeah, so this way we are going to arrange the exam. Any question now? Any question? Good. So now, what you guys prefer, guys? Would you like to take your exam tomorrow?
I think we get the weekend would help us study just to be ready for the first test.
Yeah, I'd rather take it on
personally would need the
Tuesday.
weekend to review.
I'd rather be able to do the practice test, the homework, before the test. I mean, I'll be prepped, especially on Tuesday, because I'll have all that time to be able to do it and understand all of the questions and such.
Christopher, what do you say?
I say Tuesday because we have time to prepare and do the practice test.
Got it. Is?
Sorry. It doesn't really matter for me. I mean.
Oh, that's good. So you are with me on Friday, right?
Yeah, I'm fine to take it on Friday.
Okay, so one guy is there. Oh, okay.
Or Tuesday.
I appreciate. At least one is with me. Rachel?
I'd say Tuesday, sir.
Ooh, okay.
We're not going to be doing anything over Memorial Weekend, so.
Simon?
I mean, I'd be fine with Friday. But yeah, I'd rather take it Tuesday just for more prep time.
Oh, only East is my friend. See, you guys are not my friend. No, I'm just kidding you. Okay, then Veer?
Sir, I would be fine taking it either time, just like Ish.
Pick one.
But the test, I would be fine taking it Friday or Tuesday.
I said pick one.
Oh, well, if the majority of the class wants to do Tuesday, I'll also say Tuesday.
I'm asking your opinion. I'm not asking you about the others. I'm just asking your opinion.
I'll say Tuesday to concur with the majority.
Oof. Okay, Andrew?
I'm okay with either day. I mean, I'll just prefer Friday to get it over with.
Friday?
Yes, sir.
Wow, good. 2 guys. Then Christopher Audio, you said. I'm sorry. Then Walker? Walker Powell. Hey, is Walker or Walker?
Walker.
Walker, sorry. Yeah, go ahead.
I'd say Tuesday. Give us extra prep time.
Okay, Nick?
I'm personally fine with Friday, but that's just me. I can do any day. So.
Okay, 3 guys with me. Alexis Davis.
I prefer to take the test on Tuesday.
You prefer on Tuesday?
Yeah.
You disappointed me. No, that's fine. I'm kidding you. Lazara. Lazara.
I think
Alexis, you're good. I'm just kidding you. Yes, go ahead, Lazara.
I also think we should take the test on Tuesday.
Jonathan.
Tuesday for sure.
Heavener.
Say Tuesday.
Oh my gosh. Okay, majority wins. Okay, then I forgot your name. Shafar?
Sheriff, sir. Definitely Tuesday.
Your name is Christopher, right? First name? Chris?
Charles.
Joss. Okay. Joss. Tuesday. Okay, Cooper?
Tuesday for sure.
Robert. Glasgow.
Yeah, Tuesday, sir.
And John Marshall.
Yeah, it's got to be Tuesday for sure. Got to be Tuesday.
Thomas Williamson.
Definitely Tuesday.
My goodness. Okay. Majority wins. That's fine. On Tuesday, that's fine. So tomorrow we will be learning something and then okay, good. Tomorrow is Friday, right?
Yes, sir.
Yes, sir.
Okay. So, but make sure, guys, tomorrow I have to start the new chapter. I don't have any other option, please. Is it okay?
Yes, sir.
Yeah, that's no problem.
Yeah, it's a summer course, so I can't waste 2 hours, right? At least we are going to learn something at least for some time. So please. Okay, guys, so that sounds good. So now let me go through the numerical integration. That's the last portion of this part. And so far, I have not given you the practice test for what? Left-hand rule, right-hand rule examples, right?
Yes, sir. Yes, sir.
That's not included in your article 5. Whatever practice test I provided you. It's not.
Yeah, it's not in there.
Yes,
Yeah,
sir.
so I will try to fix some examples and send it to you very soon. Okay.
Yes, sir.
Sir.
Good, guys. So numerical integration. Let's start with this one. Numerical integration. Now, guys, look at over here. Sometimes, suppose I ask you some integration like this, e to the power negative x squared dx. How will you solve this integral? You cannot use u sub over here because if you write u equal to x square or like this, right? That means your derivative of x square is 2x and x is, or 2x doesn't appear inside the in the function as an integrand. How can you take this integration? You don't know any other method, right, so far. And you are looking for the integration of this type of function. So that's why all these examples, all this type of examples, because right now you have very restricted knowledge of integration, you want to solve this integration, so that is not possible. So numerical techniques, there are few numerical techniques which will provide you the approximate answer, but very, very, very nearer to accurate answer of the given integration. So that is the use of numerical integration. We are going to learn over here 2 rules. One is trapezoidal rule and second is Simpson's rule. Here it is Simpson's 1/3 rule, and I think we are not going to go over the another rule that is called Simpson's 3/8 rule. There are 2 Simpson's rules. One is 1/3 rule. Second one is, why it is 1/3? Because it is divided by 3, just 1/3. That's why it is called Simpson's 1/3 rule. Another rule Simpsons figured it out, that was 3/8 rule. So 3 divided by 8 rule. But that is different. That's not in the syllabus in our book. So that's why I just skip that part. But just keep in mind this thing. There are 2 Simpsons rules. Okay, first rule says that whenever you are looking for integration of the fx, so that is approximately, not exactly, given by h by 2. f of x1 plus f of xn plus 1. So first point, value of the function at the first point and value of the function at the last point, last partition, plus 2 times all intermediate values of the function, all in the intermediate value of the functions. Look at over here, f of x2, f of x3, x4 up to xn. x1 is associated here, xn plus 1 is over here. So first and final points are coincided over here, and rest of the points, they are multiplied by 2. And this big bracket complete. Oh, I forgot. Big bracket complete, like this, big bracket, big closed bracket. And here it is h by 2, divided by outside h by 2. Big bracket here is like this, like this. H is nothing but your delta x, width of the strip, width of the rectangle, delta x. A to b fx ds h by 3 fx1 fxn plus 1. Exactly same as this one, only thing is here is h by 3. But now the small difference is there, only even numbers. Look at here, x2, x4, xn. Only even numbers are multiplied by 4, and all odd numbers, f of x3, f of x4, f of xn minus 1, all odd numbers are multiplied by 2. And h is same, delta x b minus a over n. Delta x, that is b minus a over n. Simpson's rule is more accurate than the trapezoidal rule. You will be seeing that thing very soon. Suppose I have integration 0 to 4 root x dx. That is the example from a practice test probably. Root x is the function, just don't worry about this. Integration is 0 to 4. 0 to 4 means it is 0 to 4. Just look at 0 to 4 over here, 0 to 4, like this. Root x means y equal to root x means y square equal to x, means it's a parabola like this, parabola like this. So root x is just the parabola on the upper side, parabola upper in the first quadrant. Y square equal to x is a parabola in first and fourth quadrant, like this. Root x is the parabola just in the upper part, and negative of root x, that is over here. But we don't have it, we have just root x, so that is upper part. My n equal to 4 means I am going to get 4 partitions, just like your Riemann sum. So my first partition, how can I get the partition? Delta x equal to b minus a over n. B is 4, a is 0, n is 4. So 4 by 4 is 1, means length of each partition is 1. So my delta x means h is 1. So delta here 1, then 2. So 4 is divided into length of each partition is 1. So 0 to 1, 1 to 2, 2 to 3, 3 to 4. Just like our Riemann sum. First point is x1, x2, x3, x4, x5. This x5 is considered as of xn plus 1, f of xn plus 1. This is x1, n plus 1. For trapezoidal, all 3 midpoints, I mean to say all 3 numbers, x2, x3, x4, and value of the function at these 3 points, that is over here. First, so value of the function at the first point and the final point, first point and the final point, they are together at the first level, then all other points are multiplied by value of the function and all other points are multiplied by 2. Use the calculator and get the answer. That's it. Whenever you want to plug these values, how can you find these values? F of x1. F of x1 is 0, right? My fx is root x. x1 is 0. So f of 0 is 0. Look at here, my left side. F of x5. x5 is 4. So f of 4 equal to f of x5, f4. f4 means square root of 4 is 2. So 2. F of x2. x2 is 1. So f of 1. Square root of 1 is 1. So 1. F of x3. x3 is 2. F of 2 is square root of 2. So square root of 2. Like this. So you can write down these things separately like this and then plug the values. And this will remain the same for this one too. So root x dx equal to h by 3 f of x1 plus f of x5. Even numbers are just multiplied with even numbers multiplied by 4, odd numbers multiplied by 2. Even numbers means how many even numbers are there? x1 and x5 already have gone at the first level. Then after you have x4 and x2 and x4, even numbers. So these 2 numbers are multiplied by 4 and only one odd number is multiplied by 2. So x2 and x4 are multiplied by f of x2 plus f of x4 multiplied by 4, x3, f of x3 multiplied by 2. Again, you are having all the values over here, just plug the values here. But because your even numbers are multiplied by 4 and odd by 2, it will give a little bit different answer. Here it is 5.15, 5.25. If you go for the integration, suppose exact value. What is the integration by Riemann integral technique? Power rule, x to the power half. So integration is x to the power 3 by 2 by 3 by 2. Agree? Getting me or not? And range
Yes, sir.
4.
Yes, sir.
Second fundamental theorem of calculus. Range is 0 to 4. If you find that is called the exact value. If you do like this, you're going to get, look at here, 5.333. So which value is nearer to 5.3, 5.33, 5.25 or 5.15?
5.25.
Right? That means Simpson is more accurate than trapezoidal. Am I right? Because Simpson value is nearer to the exact value than the trapezoidal.
Is that every time, sir, or just sometimes?
Yes, every time. So Simpson's 1/3, Simpson's third 8 is more accurate than Simpson's 1/3. But I don't know why that one is not in our syllabus. But Simpson 1/3 is there. If you Google it, you can find that one too. So Simpson is more accurate than the trapezoidal rule. Second example again.
Can you use the Simpsons in every example though?
No, you cannot. Instead, unless I ask you, use the numerical technique or use the Simpson or trapezoidal rule. Only in that case, you can use this one. If I say use the summation formula, summation formation or Riemann sum, in that case, you have to go for the partition. If I don't ask anything, in that case, you can just simply go for the integration technique, power ruler like this. Okay, but if I specifically mention that use trapezoidal or use Simpson, you don't have any other choice. Otherwise, you cannot use that rule.
Yes, sir.
Okay. Second example, just similar. Look at here, x to the power 4, like this function. H equal to delta x, b minus a by n equal to 4, 1 minus 0 by 4, 1 by 4. So 0 to 1, each length of each partition is 1/4. So 1/4, 2/4, 3/4, and 4/4 is 1. You last point must coincide with your last partition. So 0, then length, first length is 1/4, 2/4, 3/4, 4/4 is 1. x1, x2, x3, x4, x5. fx is x to the power 4. So f of x1, first find the values, is 0. F of x2, x2 at 1 by 4, that is this one, x3, x4, x5. So trapezoidal means my first x1 and x5 together, 0 plus 1, so 0 plus 1. And 2 times all other values. And that's the answer, simple. And my Simpson is, here h is 1/4, so h is 1/4 and 1/3. This part as it is, only even numbers are multiplied by 4. Even numbers means, here it is 2 and 4. So f of x2 and f of f4, they are multiplied by 4. F of x3 is multiplied by just by 2. Look at here. And you are getting 0.205. Here are 0.224. And if you find the exact value, you are getting 0.2. So which one is better? See, 0.2 is here, 0.205 Simpson S, and trapezoidal T 0.22 is here. So my exact value is Simpson is approaching to the exact value from right side. And that is more accurate than the trapezoidal, but trapezoidal is far from right side than Simpson. Agree?
Yes, sir.
So that is the end of your syllabus for the first exam. And tomorrow, maybe, not maybe, 100%, we are going to start the new thing, and I will be posting, I will be sending you the Riemann sum examples very soon. Is it okay, guys? Okay, guys, so let me stop here. I have another class after some time, so take care, work hard, stay safe, stay happy. Thank you, guys.
Thank you very much, sir. Have a great day.
You too. Thank
you,
you
sir.
guys. Appreciate. Thank you.
Thanks, sir.
Bye. Take care.
Thank
Thank
you,
you, sir.
Bye, Alexis. Rachel. Bye. Walker. Simon. Bye.